Hello, everybody. My name is Gary, and today we're going to make um, an actual game. We're going to make a Triple Triad. So, what is Triple Triad? Triple Triad is a mini game in Final Fantasy VIII, and I also believe Final Fantasy 14. As well as some mobile implementations. I don't know exactly which mobile games it was. I believe it was one of Square Enix's apps for Final Fantasy, which included Triple Triad. Um, so we're not going to do a full one-on-one implementation of Triple Triad. Um, we're going to uh, at the core we're going to make Triple Triad, but we're also going to maybe add new uh, features in the future. Um, but for now, we're focusing first on the base mechanics, which is each party has 5 cards in their hand, and uh, each take a turn in placing a card in a 3 by 3 grid. And on each card, there are 4 values, each value corresponding with a certain direction. Um, and you can basically steal your opponent's card by uh, by uh, by placing a card with a higher value at that side. So if on the right side of your opponent card there's a value of 1, and you place one with the value at the left side of you place a card with a value of 2 on the left side, then you steal the opponent's card. If your value is lower, you don't steal it, but you also don't lose the card that you've placed. So first, let's start with actually making a page. So we don't actually have to make the page, um, but it is, yeah, well, eventually we'll need the page to display something. For now, we're going to for a pure JavaScript implementation with with oh wait with maybe a either a canvas implementation um, or a DOM version. But let's first start with creating the HTML page. HTML head title, and we're going to name our game just a Triad card game. Uh, let's start with body. So, what are we first going to do? Um, we have triad.js. Um, okay, let's start with creating several smaller files. Why? Well, because it's easier for us to later implement it in other engines, or not exactly other engines, other yeah, well, technically other engines, and we can also in the future use it for Node.js. So let's call it script and move this one here. Let's move it. Yeah. Next, we're going to add a new file called um, objects. we're going to store every object in here. So we have object and we have triad. Um, what I rather do is actually split everything up in smaller pieces, but uh, for now, just making a objects.js file is good enough. Um, why? Because we're going to extend classes, and it's going to be hard to extend classes if and then reference other classes if these classes aren't made the moment they're needed. So if you do class test extends a, and a the file with the class a hasn't been initialized yet, this is going to cause an issue. Especially if we want to asynchronously load in every script file or JavaScript file. So first we're going to save this, and then we're going here. We're going to link rel style sheet, and I believe href is triad.js css. Okay, now it's found. What I also need to do is script source is scripts dot slash objects.js async, because we're going to asynchronously load every object in. Let's also make a script file called debug.js, or well, it's technically not debug.js, but maybe we can add some debug functions in there and add debug.js. Maybe load in debug.js first. I believe I'm not 100% sure, but async I believe still loads every script file in order. But again, I'm not 100% sure. So first console clear, and now the console is cleared. So every time we're changing something about the script, the console will constantly be cleared. So let's create object. So first, what do we exactly need for Triple Triad? Well, for that, we're going to open something else up. And maybe we can actually create a new file for it. No, let's not create a new file. So first, what do we have here? We have data, we have images. So the images are just your regular images that you can actually use, or that we are going to use for the cards. I'm not sure if we're going to use these images now, but eventually we will. So maybe in a future stream, I don't know. So what we also have is the data file. So we have a dex.js, and this contains every deck available to us. And we have zapekist.json. This is going to be our Zapekist themed deck. So I haven't completely finished it, so I'm going to remove this one. We're going to just use these three cards. Just a moment. So okay, next. So okay, the zapekist.json contains just the name of this of the deck, and the different kinds of cards. You have 2 level 1 cards and 1 level 4. And these levels don't actually have any effect on the game itself, but it does have an effect on the rarity, and why rarity will I'll be explaining it later. Um, so what do we exactly need? So let's open a new document, um, and let's write requirements. So what do we first need? We need first of all a card, which is pretty much obvious. We can't play a card game without a card. Okay, let's not use uh, ordered list. No, let's use an unordered list. What we also need is a deck. What is a deck? That's the cards you have in your possession, but those are not the cards in your hand. That's another uh, thing we need. What we also need is a field. We need a playing field. So in our case, it's going to be 3x3, but we don't want to limit ourselves to just a 3x3 field. So next thing we need, and okay, let me check, because I did make an assignment on work for this. So we need a card, we need this playing field. So what do we also need? I think this is it, but extra, we also want a booster. What's a booster? That's when you basically pull a card from a pack of 5 cards and get random cards. And this is where the level comes in handy. We can use that level to determine the weight for each individual card. The higher the rarity, the rarer, the higher the level, the rarer the card becomes. So let's check it out. So what I also had is a field position. So what does a field position do? A field position basically represents a spot on the playing field. Why do we need a field position object? Um, um, well, the field position has properties for the card and the player. As Triple Triad in the Triple Triad games, you can basically steal an opponent's card. So we need to we don't need to keep track on which card is whose. But we do need to know which player possesses the card at that time. Um, what do I mean by that? So you have a card, and yeah, let's say a Thornberry, and this is player 1. But once it gets captured, it needs to be belong to player 2. However, this part will always stay the same, because well, a card is just a static thing. We just need to know if that card is belongs to player 1 or belongs to player 2. So that's why we have field position. might seem a bit redundant or unnecessary until you uh, until you figure out that the use for it. Um, so let's see. We have a card game. We have a card. Oh yeah. Uh, Another extra thing is a set. So each card can belong to a certain set. Um, like I said, it's you have the Zapekist deck, or actually it's the Zapekist set. So everything belonging to the Zapekist set will, well, yeah, belong to the Zapekist set, and that influences the booster packs. Booster packs don't actually contain the actual cards; it contains a reference to that card, essentially. Um, okay, let's see. How do we do this? Okay, first let's start with um, hmm, maybe we can first start with a card. So class card. And what does a card have? A card has, well, it has a name, it has an image, it has ranks, and it has a level. Um, Let me check. Um, and technically, it also has an ID. Um, so, let's see. Maybe it's better to just say, just define each and every single class we need. So we need a class deck, class card, a hand. So let's do class hand, um, field and field position. Class field, class field position. Let's move this one above. So um, let's see. How do we basically do this in the best way? Um, well, we know at least one thing. Um, we need card, at least card. So let's first define the appearance of card. So why can't I use tab? S. Okay. Weird. Um, okay. Um, so let's define the property. Um, First, the card has a name. It has it has ranks, and it has a level. Also an image. So let's also rearrange this. We want to rearrange this in alphabetical order. So constructor. Um, we want, okay. Card at least needs an idea. Oh no. Let's let's first create a simple thing. Name. Ranks. Level. Ranks. And image is null. So image will become an optional thing. You don't actually want an empty image, but um, just in case you want to later replace the image, whatever, we'll set this to null. So first, this name is okay. What I also want to do is I want to make all of these private except for image. Image can be modified however you want. Okay, let's see what else. So this level is level. This ranks is ranks, and this image is, let's reorder it by an alphabetical order and save. So next, what I actually need is class set. So let's actually set to here, because this is going to make some things a bit easier. And a set has at least a name and parts. Constructor name, and we only need the name part. Parts is going to be, it's not going to be an array, it's going to be this an object. Okay, I think I am going to make image private, because I don't want image to be changed afterwards. And there's a good reason for that. So let's go here, constructor name, this name is name. Next, we're going to add a new method called add card. And let's call this card. And to keep it simple, we're just going to do no, let's change. Let's move this one down. Okay. What does add card do? If card instance of card. Oh, let's also add ID, because we do need the ID. So if card instance of card, so let set card is card. And what we also want to do is, if this isn't an instance of a card, we need to create a new card. So let's set card is new card. And then we're going to do card dot name, card dot level, card dot ranks, and card dot image. So yeah, that's going to be it for now. We're going to assume that the card here is either an object, well, that it at least is an object, and if it's not an instance of card, then we can create a new card instance from it. If it's not an object, then it's going to be an issue. Um, but for now, because we're going to close it down, it's not going to be a big issue. In the future, in when we want to make it more public, we do need to make sure that it is an object, not a string or not a number or whatever. But that's not important for now. For now, we're just focusing on creating the basics of Triple Triad. So let's now start with this cards, and this is where we use the ID. This card is a set card. So why did I use this and then just the set card is this? Technically, you can just forego this step and just use this, and JavaScript won't complain about it. But the main problem with it is linters. Most linters, so like ESLint, will complain about changing a parameter or an argument. Yeah, because it's an unexpected behavior. So next, what we want to do next is so let's already say that all getters and setters go before every other method. So if we now want to do get name, return this name, then it goes first. It doesn't really matter if it goes first or last in your own code, as long as you're consistent. So if you're going for getters first, setters first, and then all the other methods, or you do setters first, getters first, and then all the methods, it doesn't matter as long as you're consistent within your own code. So you shouldn't do getters first here, and here you're going to do getters last, because that will cause issues. So next, let's create getters and setters for this one as well. But actually, we only need getters. So get image, turn this image. Get level, return this level. Get name, return this name. Now for ranks, we're going to do something different. So let's get ranks, and we're returning the ranks array spread out in a different array. So we're basically making a copy of the ranks array. So what do I also want to do? And I'm going to reference my own yeah, I get it. I think I got it. So next, what do we want? We want to do a comparison. Um, so why do we want to compare? Well, it's simple. We actually want to compare two cards with each other in a certain direction. So write let's write compare other card and a direction. Um, so what do we? How do we do comparisons? So let's do. So what do we want to do with compare? Well, say you have a card and you want to compare it with another card in a certain direction. So you place a card here, um, and you want to compare it with this card. So you're going to take the value of left and compare it with this card's value of right, and that's what this basically does. It compares two cards, and the direction you define here is the direction of the current card you're comparing with the other. Um, so we're not going to write code right away. What we're first going to do is we're going to um, what are we going to do again? So let's check it out. Oh crap. Um, I do need to change something about this because this is supposed to be numeric. So okay, next what we're going to do is so what we first want to do is set the basic uh, layout of our code. So we have a compare method and we want to have a toString method. So the toString method does basically nothing but allow us to see in a string form what card it is. Let me check something. Okay. Let's go here. I need to make sure that my stream actually works and that I'm not talking to air. Yeah, I'm not talking to air. That's fine. I've been having some issues with my stream, and that's because OBS has some trouble with my Ethernet cable. Yeah, stream does seem to work. Yeah. Um. So what we do have is a toString here, which is important. So now what we're going to do is we're going to write the compare method. Well, before we do that, we're going to do something a bit different. We're going to add some constants here. Constants are values that are constant. However, there's no easy way to define constants in JavaScript. Um, let's check because uh, yes, JavaScript keeps evolving, so uh, declaring static constants, and I believe it doesn't work yet. So yeah, so we're required to do this object define properties, and we're going to pick an object. Well, the thing is, a class we need to we need to define it on the class itself. So okay, I did maybe I haven't explained it in a previous stream, but a class technically also functions as an object in itself. Just like a function is an object, a class can also be an object. So what you can do is card dot test is one, and you can do console log card. And let's first comment this out so that we don't. And so now we can actually see the layout of the card class. If you do card test, we can see that the value is one. So we can define properties on the card class itself. But we also, but what we want to do is we want to define static properties. So let's do card and then do let me check. Yeah. So yeah, it would have been nice if there was something to allow static constants, but there's no easy way, so we need to do it like this. So what we can do is direction top 0, direction right 0, but even this isn't exactly how you can do it. So what we need is helpers.js. And this is where we can actually check if what we want to do actually works, and that is well, here we can check if async actually does what it says it does, meaning it loads each script file in sequence despite the async. So to further explain what async does is async loads the script files while the rest of the document is loaded, but it will try to load the script files in sequence. So so for example, maybe this HTML file is 1 MB or 10 megabytes big long, and it will take some time to render that HTML page, but in the meantime it will try to load each script file in. So what we can do is console log debug, and let's do helper. And yeah, as you can see, they are loaded in sequence, so we don't have to worry about that. In fact, what we could do is split this up in smaller files. Maybe I'll do that later. So what we want to do is we want to make some helper function. So let's create a function called function add constants, add static constants, a class object, and a static constant. So next, what we want to do is const object properties is, and we're going to do some hoops. So object dot keys static constants dot reduce. So what does reduce do? Reduce is mainly used for arrays. Let's give you an example. Let's say you have an array const numbers is 0, 2, 4, 2, 1, 3, and you want to add each number you want to know the sum of every number in this array. So what you can do is console log numbers reduce, and then previous value, current value, and you can also define current index, but we're not going to use current index. We're just going to use this. What we're going to do next is, this is going to be a function. The first parameter, the first argument is going to be a function. And what this function does is, it can use the previous value, and you can do something with the previous value and the current value. So if we do previous value, current value, then the output is going to be 12. And just to be sure, you can also set a initial value. So if right now the output is 12, if you use 10, it's going to be 22. So 10 will be the previous value at the start. 10 plus 0 is 0, is still 10. And so forth and so forth. So if we use 0, previous value 0, plus 0 is 0, plus 2 is 2, 6, 8, 9, 12. So this is what reduce basically does. It reduces an array into one value. And that same thing is what we're going to use for this. So object properties, we're going to reduce it. Previous, well, let's not call it that. We're going to call it object. And this is key. And let's do this. Initial value will be an empty array, or empty object. So what we're now going to do is object key is, and okay, so what we're going to const new object is object. This is really redundant, and normally you don't have to do it, but because I'm conditioned by ESLint, this is what I often do. So next, what we need to do is this. Okay, wait. Define. Okay, maybe I can even do it simpler. Let's see how it works. Oh yeah, okay. That's simple. So const constant info is okay. So I've copied this from somewhere. Let's remove this. We're going to set writable and configurable to false, and the value needs to be set to static constant p. So what we're going to do is, we're making a new object with value of the original value. So say we have, and let's just do it right now. So add static constants card and use direction up top is 0. Then for direction top, the value will be 0. Next we're doing a new object. Key is constant info, and return new object. So next, what we're going to do is, we're going to apply these object properties to this class object. So object define properties, class object, object properties. So how this works is basically you have an object, say const test is just this, and we're going to do object define property test, and then top, and what we're going to say is the property top has a value of 10. If we now do console log test, we can see that that there's a new property called top with a value of 10. Okay, add static constant. Is that correct? Okay, yeah. Okay, so anyway, so top the property the newly defined property top has a value of 10. So if we now do test top is 10 100. Okay, so now we can see that the value 100 doesn't get overridden. The value top doesn't get overridden with 100. And to completely ensure it, we can define these properties so that's not writable, it's not configurable. It's not really required, I think, but it does help. And what define properties does is it allows you to define multiple properties. So in this case, we can do a top and then you'll basically have the same thing, except you can now also use bottom, and then you'll have both top and bottom. And that's basically what this piece of code does. It converts this into what we've done here. So in this case, what it does is we have this object. So const static object is this, and then it goes through each key. So direction top, direction right, it's 1, and then it converts it to this object properties is direction top, value 0, right double false, configurable false. Then it goes to the next key and does exactly the same but with value 1. And in the finally it uses this class object, in our case card, and then applies these static properties. Direction right, well technically they're not static properties, but they function as such. Direction bottom 2, direction left is 3. So we now have defined the 4 directions, top, right, bottom, and left. So what we want to do is, if we check the top direction, we want the bottom direction of the other card. So first, let's get our own rank, const. Well, we don't actually need to get our own rank because it's just this. So what we need to do is our rank is this ranks, and then direction. Next, we need the other rank. But how do we get the opposite direction? Well, there's a reason I've picked the value 0, 1, 2, and 3. So from top to bottom, there's 2. From right to left, there's also a difference of 2. From bottom to top, there's -2. But if you just add 2, we get 4. And when we use a modulo, we can get 0. So modulo 4 is 0. And the same goes for 3. Modulo the 3 plus 2 is 5. And that 5 modulo 4 is 1. Because 5 divided by 4 and is or the remainder of 5 divided by 4 is 1. So the other rank is this ranks direction modulo 4. Or not that, direction plus 2 modulo 4. So to keep it simple, we're going to only use values 1 to 9. So 1 through 9. And we want to check if it's if our card is higher, we want to return a 1. Otherwise, we'll return a 0. Or we can also use true or false. So return our rank higher than other rank. Later on, we're going to adjust it to add some of the special rules of Triple Triad, as well as the A's. I don't know if there was a special rule about the A's value. But for now, we're just going to simplify it. Okay, let's check what else. I do need to know what the A means in Triple Triad. So maybe there's the A just stands for 10. Allows cards with 8 to be captured by cards with 1. Oh yeah, it's for certain special rules. Yeah. Okay, let's allow value 10, which will be displayed as an A. Oh no, okay, this is wrong. I need to use other card ranks. So yeah, this is how we're going to do it for now. So next, what do we want to do? So we know how to add a card. What we now want to do is get the card. Get card ID. So get card ID is pretty simple. What we're just going to do is return this card's ID with a null coalescing operator, so that if the card can't be found, null is going to be returned and not undefined. So yeah. Okay, so let's see. So I did tell about static methods. I do need to check if there are static fields or static properties. So yeah, static properties are also a thing. Why is that important? Because we also want to add some static methods for set. So normally static methods, I believe, go before normal methods. And the same goes for property. So but you can define for yourself what the order is. I choose to place static methods and static fields first. What I'm going to do is static sets, and the static sets is going to be private. So static methods still go after the constructor. So what we're now going to do is a static add set, and I want to make it private. And the set has an ID and set. Yeah. Next, what do we want? If set instance of string, okay, not that, type of, oh no, okay, let set is set object is set if set instance of set, then if set no type of set is string, oh, let's just do object, then we're going to do set object is new set, um, yeah, so we're creating a new set object with the name set. Well, yeah, if but only if it's a string. Oh no, if it's an object, we need the name property. Otherwise, set object is new set. Yeah. There's one thing I do need to check. That is console log field instance of object. Okay, I can work with that better if I use x, and it's false. If I use 12, it's false. Okay, I think that's a bit better. So let's remove this instance of object. So yeah, actually we don't need this because this is a private static method. We can just remove this and just do and we do need to use ID here. So what we're going to do is so how do you reference static properties? Hmm. Hmm. I haven't used static methods in a while. So does this work? Yeah, this does seem to work. Yeah. Okay, so if I just do this cards, ID is set. And then what we're going to do is set add set ID and then this. So let's check if it's going to work. So if we do console log set, um, okay, for now we do static get sets, return this sets, get sets. So now right now it's undefined, which isn't correct. We need to make this an object. And if we do now do new set zapekist cannot read private member cards from an object whose class did not declare it. Wait. Cards. Add set. Oh, this has to be sets. Yeah, this okay. So now this works. So we're going to remove these two lines. So from here on out, I might not say to a lot. Static get card. So what we wanna have is we wanna get a card ID card ID is null. If so, let card ID real card ID is card ID. If card ID null, then so okay, let ID is no real ID. It's ID. Then what we need to do is, and we're okay. What I'm going to do is something I also haven't explained, and this is destructuring. So first I'm going to real no, ID dot split. Okay, what does this actually do? So ID split. Let's go here. So if I do ABCDF and I do split this, then it splits this string into two separate strings, separate strings, or yeah, it splits it into an array of two separate strings because we're separating it where the colon is. Now, what am I doing here? Well, let's say we have let value A and let value B, console log value A, value B, and they're both undefined. So if I do this, value A, value B, so these two are in square brackets. And now I do ABC, DF, split, and then enter, and I go back to this, you can see that value A now has value ABC, and value B has the value DEF. So normally what you want to do is const value C, comma value D is ABC F G H I J K L split, and then enter, console log value C, value D. So that's how you can destructure an array. You can also do const value E, value F is 1, 2, 3. So now console log value E and a value F. They now have the values 1 and 2, and 3 is getting discarded in this case, which is in our case pretty much ideal, unless you want to keep part of this, but we're also already establishing that an ID can't have a colon. At least that's what we're going after. An ID shouldn't have a colon, because that's going to be a problem when going through the folder structure. So now we have the real ID and the real card ID. So what we're now going to do is this sets real ID dot get card, real card ID, and we're going to return this. However, it might occur that it might be that a certain set doesn't exist with a certain ID, so we need to capture it. So when we add this question mark, we're saying that if this doesn't exist, we're going to basically ignore the rest, but we need to return something else. In this case, null. So if the set doesn't exist, it just returns null. So can we test it? Sure. So let's do const card is new card, non-vary, level is 1, ranks is 1, 1, 1, 1. We don't need an image. Then we do const set is new set. We're going to call it ff, and of course we need to define the name. Finally, we're going to do const retrieve card is set get card f. Oh, all right. We still need to do set add card, get ID Thornberry, and the card. So what we can do is Thornberry, and then okay, wait. Get card is not a function. Okay, get card. So what happens if I do console log this? Oh, and I shouldn't use a private here. So let's do console log retrieve card. So card. Yeah. So right now we have the proper card retrieved based on just the the set ID and the card ID. So right now we have this implemented. Let's go on with the rest. Or rather, let's go here. What we're going to do is we're going to initialize loading. So let's do first do function load data, and we're going to make an asynchronous function. Load data. So first we're going to const response is, well, let's not make this a constant maybe. Let response is await fetch that data dex.json const dex is response.json, I believe. Let's do console log dex load data. Okay. So maybe we do need await here. Yeah. So now we have the deck data. It keeps flashing. Okay, so I need to check what it is. Are there other? No, there's no other. No one else. Okay, so I believe Yami is streaming right now. Um, or not. Hmm. Okay, so sorry for getting distracted, but okay, so let's continue with loading the data. So we have the deck information. So what we now need to do is go through each deck. So we have a problem here. We can't use for each. Why? Because for each runs basically runs in a separate loop. So if we try to do decks for each, we can't use wait here because there's nothing to wait for us. So let's see deck and deck console log deck. Yeah, it's for simple things like this it will work, but if you turn this into an asynchronous one, it's not really a good idea. It won't wait until the previous information has been loaded. But we can fix it. So instead of using for each, we're going to use reduce. And as a default value, we're using promise resolve. This one will actually just return a promise. So let's previous promise deck ID. So what we're first going to need to do is wait until the previous promise has been fulfilled. So let's do previous promise. And at the end, we don't actually need to return a new promise because this an asynchronous function always returns a promise. So if we do this console log, we get a promise in return. So the return value of the of a asynchronous function is basically, so if we do return x, so let's see, const promise is load data, and pr then value console log value, and that's going to be x. I believe I've already mentioned it in my previous stream, but just as a reminder of how asynchronous functions work. So what we're now going to do is we wait until the previous promise has been done. Then we go to the next deck ID, and we're going to use the deck ID. So response is await fetch, and we're going to use data dex deck ID .json. Next const set is await response JSON. Let's do console log set, and we are going to use load data as is. So as you can see, we now have the data for the Zapkist set. So what we're going to do now is use a new set deck ID and set dot name. Well, let's change it to set info. So, okay. Is there anything else? So this works. Next, we need to make the cards. So let's do console log set info. Why do we do this? Because sometimes you don't want to go back to these files and you just want to check what data is returned. So in this case, we have this. Okay, we do need to go back here. So we need to create new cards. But we can just use this to do everything. Yeah. Let's see. Yeah, let's go with that. So now let's const set is new set and set add card. Oh wait, we don't use this. What we want to do is set info cards object keys, set info cards for each. In this case, we can use for each card ID because we're not going to do any asynchronous actions anymore. Next, we're doing set add card ID, set info cards card ID, and let's see. Do console log set, and we check this cards object, then we can see we have 3 new cards added with the proper information. So now we have a simple card loader. So what can we do with this? Well, it's pretty complicated. So what we now need to do is create a deck and a hand. So what does a deck, what do decks and hands have things in common? Well, yes, they do have something in common. We can get cards, we can yeah, we can do quite a lot with uh, both. But there are also some differences. So maybe we should just leave them as two separate things. Um, yeah, but I don't know. Maybe yeah. Let's just do it as two separate things for now. Um, so yeah, okay. Frickadev, I highly dislike Jazz. Yeah, that's there are people who, it's a valid dislike. The thing with JS is I'm using JavaScript for primarily for one thing, and it's to explain how programming works. Um, in my 3 previous streams, I used JavaScript mainly as a tool to explain how programming works. Why did I use JavaScript and not Python? Python has a certain barrier, and that barrier is you need to install Python. For JavaScript, all you actually need to install is Windows or Mac OS. You don't actually need a you don't need an IDE like Visual Studio Code or NetBeans or whatever. You don't need to install special software. You can just use the browser provided like Chrome or Edge or Safari. Um, but yeah, JavaScript works pretty much out of the box. So yeah, that's why I actually picked JavaScript for today's stream and the previous 3 streams to explain the basics of programming language. Just JavaScript is a decent tool to teach the basics, like what is a variable, what is basically a constant, what's a constant, what's a class, what's an if block or an or else block, or what's a switch case, what's a for loop, um, uh, all those things that a lot of other programming languages have and most likely do better. Like C sharp arguably is better than C plus not C plus plus than JavaScript. Even Java is better than JavaScript. And yeah, I wouldn't really recommend getting too much into Java unless you want a Minecraft mod. Um, Like the things most other programming languages do better, and actually TypeScript as well, is the fact that it has type hinting. In fact, these programming languages don't work without type hinting, um, or not even type hinting, type defining. Uh, yeah, okay. Writing straight binary doesn't need any installation, but it also isn't beginner friendly. JavaScript, that's the other thing. You can teach low level programming languages like assembly to people who have never done any programming before, um, which is why languages like Python or JavaScript are perfect for beginners. Um, Maybe PHP, but I wouldn't recommend PHP on the grounds that it is not good. Yeah, I can't make anything more than PHP isn't actually a good language. I use it at work, but I wouldn't recommend learning PHP if it's not for work related reasons. So yeah, but yeah, that's why I picked JavaScript, because uh, it's it's beginner friendly. It doesn't require you to install anything. Um, Plus, if you want to go into web development, like I do, uh, JavaScript is an excellent language to start off with. Um, Eventually, I do recommend looking into things like TypeScript, maybe even Rust, because as far as I know, you can actually make web applications with Rust. I just haven't looked into it, but I assume Rust is a lot better than just use straight up JavaScript. Um, but yeah, anyway, let's start with the deck. So what we want to do is we want to define what's in the deck. So let's do cards, um, constructor, and we don't need any parameters for the constructor because we just want. In fact, I don't even think we need a constructor in this case. We just want a deck. Um, and one where you can just add a card, add card ID and quantity. Um, so, and in this case, I do need to move deck lower, um, below set. So, um, actually, we don't actually need to do this. Well, the only reason why we want to do this is to ensure that the card does exist. So, what I'm also going to do is do something I haven't explained before. I did explain how to throw errors, or how to handle exceptions. But you can also create your own exceptions. Like, so let's do class uh, card not found exception extends exception, I believe. Exception is not defined. So then error. Um, Technically, we don't need to actually define the contents of this exception. We're going to customize it later, um, if we ever getting around to it. So let's first do quantity is 1. So what we expect for this is both the set and the card. So let's now do set get card ID. Const card is if uh, if the card isn't found, then we are going to throw card not found exception, a new card not found exception. So if we now do const deck is new deck, then deck add card again, we're now getting a uncaught error. So yeah, which means something went wrong. But so we now have an error that doesn't really say anything at all, which is basically um, something that we wanna avoid. We want to have a actual um, message. We want to know exactly what the error is. Um, so how exactly um, do we do it? Well, we need to attach a certain thing. And what is that certain thing? It's taking a bit longer than I wanted to. I need to look it up. I've actually created exceptions before in JavaScript, except I don't often do it. I mostly just do it in PHP, uh, mainly Laravel. Um, but I rarely do it in JavaScript. So I need to find out. Okay, so let's just paste this here, and then I'll go through the code. Some of the code is just something I found in Stack Overflow, but it's easy to explain. So first, we're going to use super message. Super means we basically use the in this case the constructor of error itself. So we set the message um, to so okay, so we're setting the message we define here, and I believe it's optional, this message, but it's still good if you put your own message in. Um, and we use that as the argument for the error constructor. Next, we're setting the name, and the name is card not found exception. Uh, we're changing this into card could not be found. Um, Display an object, message, create missing dependency string. No, we're not going to. So let's just do this for simplicity reason. So if capture stack trace. So what this does is it creates its own stack trace, or I don't exactly know what it. Okay, uncut card not found exception, card cannot be found. If I don't do this, let's see. Okay, okay, I see what's happening here. So if I don't use this, no, I don't exactly know what this is. Stack is in the new error stack. So let's check it out. Example, so I assume that it will just, so if I just remove this, nothing much will happen. So console log x. Yeah. So I'll look into it. I'll look into what it exactly does actually, because um so it doesn't really matter if I add these uh to this, but there has to be something with this. Um so what does capture stack trace exactly do? It captures the stack trace, and the stack trace is basically um the list um of, well, let's see, how do you say it? It's the list of, it's the path it took from root to the current error. And because we've created our own exception, there might be a chance that, okay, oh, maybe I get it. So if I do try catch e console log e per stack. So this allows us to see the path it took from the root to to where the error occurred. But if I don't do this, it still works. Okay, interesting. So yeah, let's just do this. Hey, what? Add static constants is not defined. Wow, what? Okay, so yeah, okay. So next, we've got our card, but we're not actually going to use this card. So let's actually do this. So yeah, the reason why I'm using this is we just want to see if the card exists, because what we're going to store is this cards ID is this cards ID, or 0 plus a quantity. So what this does is it stores the card ID in the deck, and purely the card ID. And then first it retrieves the card ID, and if it's the card with the current ID, if the ID does not exist, um, then it's just setting it to 0, and then adds, in this case, 1 or more cards to this deck. So next, we have adding card to the deck. Um, yeah. So what do we want to do next? Um, hand. Hand is going to actually have okay, so let's do cards. Add card. Um, oh no. Yeah, this is good, but we also need deck. Constructor. Um, I need to think of how to do this properly. So let's do deck. This deck is a deck. So we're storing the deck we've created in the hand. So we know that this deck of this hand will only take from this deck. Next, we want to add a card with certain ID. Okay, I think I need to do this clone. Const deck is new deck, and then deck cards. Oh wait, deck this cards object these cards for each card ID. So now let's do deck add card ID, comma this card ID, and then return deck. So let's do deck dot clone. So we need to add a clone of this deck here. Next, we need to add a remove card. Normally, maybe I should do it in alphabetical order, but normally I group methods that are similar or deal with similar things. ID quantity is 1. This cards ID. If this card ID 0 bigger or equal to quantity. Oh, yeah, this is correct. And then this cards ID minus it equals quantity. So we're going to remove a certain quantity of a certain amount of cards. And we're return true. Otherwise, we're returning false. So we only remove cards if the correct amount of cards exist. So okay, next, let's do add card, and then so maybe amount is 1. So what we want to do is first we want to check if this card's length, because for now each hand can only have a maximum of 5 cards. So if length plus amount smaller or equal to 5. Well, no. If it's bigger than 5, return false. We don't want to throw an exception. We just want to say no, not gonna happen. Um, so what next? What we want to do is, oh yeah, we also want to check if the card actually exists. So in this case, we do want to store the card itself. So card const card is this. Finally, well, not finally, if so in this case we do want to throw an exception because we want to ensure that a correct ID is provided. If not if the correct ID isn't provided, someone has been tampering with the code or whatever. So we need to prevent that. So next, if uh, this deck remove card ID and amount, we should actually keep the term quantity. So if we can't remove the amount, then we do return false. Finally, return true. But also for let's let's iterator is iteration is 0. Let's just use I smaller than quantity. I plus is 1. Again, plus is 1 is more because ESLint. So this card push card. So what we're going to do here is we're going to push the same card this amount of times to our hand. So next, what do we want to do is we want to get a getter. Get card is no, it's a function return this cards. So yeah. Next, what? Okay, so yeah. So what we now have is a hand, a deck, a set, and a card. All we need to do now is field position and field. So field position has a card and a player. Yeah. Constructor. So card is null. Player is 0 -1. We're going to add a new constant to field position. Player none is, so let's do this. Player none is -1. Player 1 is 1. Player 2 is 0 and 1. No, you know what? Let's just do player is 0. So what I did I add to the documentation? Triple Triad card, booster, card collection, deck, hand. playing field, field position. Uh, okay, I know what it is. Okay, so no constructor needed. Place card, card and player. So do we want to? Okay. Okay, so if a card already is placed here, we don't want you to replace that card. So if this card return false. So if card isn't null, we can place a card here. This card is this position is taken. Otherwise, this card is card, and this player is player. We also want a getter for card and for player. Return this card, get player, return this player. Hey. Oh, square brackets. Okay, I think I need to zoom in a bit. Yeah, I think this is a better size. I need to reduce the size when I'm programming myself, when I work from home. So yeah, um, I think this is better if you want to actually see what's on screen. Otherwise, it's really small. So we have place card. What we now want to do is change player. So let's see. What did the documentation say? I believe if I change player, um, it only needs to work when so if no player, uh, does it need to return something? I no, I didn't specify anything about this. Uh, just return. So if I return, then it's returning undefined, which is okay. So next, this player is so if the player is 1, then it will become 2, and otherwise it becomes 1. So what I can do is 3 minus this player, because if the player is 1, then 3 minus 1 is 2, then the player becomes player 2. Player's player 1, 2, then 3 minus 2 is 1, then the player becomes player 1. Yeah. Did I do it correctly? Yeah. Yeah. And I also want to have a toString. And what does this toString method do? We're going to return card, this card toString, and otherwise just none. Um, and this player. If there's a player, then this no um, this player. Otherwise, it's an empty string. Okay. So what this does is it's when you use toString for this position, it returns the card, and if there's no card, it says none, and the player associated with it if the player is set. Okay. Finally, we need to define field. So what was the specification? A field consists of a two-dimensional array with values as values field positions. It has to be a 3x3 layout. 0.0 is top left. Yeah, top left. 2 is bottom right. 2 1 is right in the center right. Okay, yeah. So const grid. Oh, no, not const. This doesn't work. Constructor. Why do we do constructor? It's simple. So let's first define width is 3, const height it's 3. Why do we define two constants if they're just going to be static anyway? Well, this is for future proofing. If we want to make game modes that don't adhere to the 3x3 grid, it should still be possible. So what if we wanted to define a grid of 9x9, for example? Actually, the same needs to be done for player, actually, or for hand. Oh, field is null. Field is null. This field is field. So let's define another constant. Const grid size is oh, okay, wait. We can do size, but cells is field get cells or 5, and it has to be this field. And I do need to place this below. So field instance of field, otherwise it's still null. We're going to add this here. So yeah. And this also means we need to add a get cells method. and we're going to add height and width. This also means this width is width, this height is height, and then we need to return this height times this width. Next we need to so for let x, okay, let's do initialize grid. And do we need to make it private? Yeah, we're going to make it private. So what we're going to do is this initialize grid. For let, so I did define xy. So yeah, let x is 0, x smaller than this width, x plus 1, or let I 0, y smaller than this height, I plus is 1. So let's const column is an empty array, const no, it's not column, it's rows. Const grid is empty array. Then we do row push new field position. I believe field position was just, yeah, like this. And grid. Why didn't I just do this grid? This grid push row. Row. Is it row or is it column? Yeah, it's column. Normally I invert it. But for simplicity, I didn't for the assignment. So do I want to switch it up? Yeah, I do want to switch it up. I think no, I don't want to switch it up. It's easier when I output the output everything with toString, but it is going to be a bit harder for everything else. So what I'm going to do is I'll create a toString, and this is what I need to change for, I believe. Okay, this doesn't, does this has a, okay, this, it's good. Okay. I don't have a private method except for here. So here I need to do toString const inverted axes is empty things. So what I now need to do is invert it here. const rows, and then rows push this grid x y, and then here I do inverted axes push rows, and I can do console log inverted axes, and I'm going to later implement something else. No, wait. I don't even need to invert the axes. I can just, okay, so let's do let output is an empty string. So output is going to be this. Yeah. Let row output is yeah. Row output is row output. No. Let's do this first. And output array raw output push this grid x y to string. Output array push row output, and then no, not raw output. We're going to join this with a comma. Not just that, we are going to wrap it up in this. So yeah, and then return output array join comma. So now it's in one string. So if we do const field is new field to string, console log field to string. Rows is not defined. Where is rows then? Is it an initial? Is it, of course. Card none. Yeah, that's exactly what I want. So what next? We basically have almost everything, I think. Let's see if we miss something. Place card. So with the field we can use place card. So let's card xy card and player. Um, so, okay, let's simplify this by removing card here. So now we see none, 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 none. Hmm. Mm. Okay, let's just keep it like this and do something simple with it. If x smaller than this, than 0, um, or x larger or equals to this width, or y smaller than 0, or y bigger than or equal to the height, then return false. We can use we can throw an error if we want, and maybe I will make an exception for that. But for now it's good as it is. So let's do that. Let's do return this grid x, and this is why I use x first and y next, and now why I need to invert it here. Is yeah, this is the reason why. It's easier to see what x is and what y is. So we know that this is a field position, so we can just do um, place card player. Yeah. So we've done that. Um, I believe there are some more things we need to add. Get card, get player. Um, okay, this is also good. So first do get card xy. So what we're going to do is copy this, return. We could use this again. What we're instead going to do is get is valid xy return um, so we wanna have so this if this if the position falls out of range, then this value is going to be true, but we wanted to get it to get a false value in this case, so we change it to false. Yeah. Blah. Ooh wee. This is quite tiring. I did expect this to be long. Um, Didn't expect it to be this tiring. So let's do this. So if this get is valid, x, y, return false. Otherwise, the same goes for here. So let's now do card. Yeah. Get cells, get player. Now, we have get card, we have get cells, we have get players. What we also want to know is get score. What does get score do? Get score. Get score shows us three things. First, how many uh, empty spaces there are. How many uh, how many of these spaces are belong to player one and how many belong to player two. So if there are no empty spaces, the game ends, and the total score is going to be defined by the output of get score. However, uh, we also need to take into account the hand. So what I'm also going to do is, and this is going to be a bit tricky because we don't want a circular. We don't want circular dependency. That's interesting. Uh, okay, get score only gets the score of the current field, and afterwards you need to see which player still has one or more cards. Um, yeah, let's just go with that. The final score is going to be determined by um, yeah, by the cards that are going to be left, I think. It's the final score needs to be calculated afterwards. So let's change this to get field score. So let's do const score is 0, 0, 0. This grid for each. I believe column. This grid for each row. And I know I should actually use a reducer. Yeah, let's just use a reducer for this. So let's return this grid reduce previous score and column um, let's set this to 0, 0, 0. Then column reduce previous score sub row previous score. In this case, I do want to use a normal function, so let's now do new previous score is previous score sub new previous score row dot player plus is 1, and then return new previous score. So if I now use this on a new field, const field new field, and then field get field score, so log, it's going to be 900. Yeah, it's 900. Okay, correct. 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 Okay, Shane. So we have everything implemented from field. Let's collapse it. We also have everything implemented from field position. Do we have everything for the hand class? Card collection, hand. Okay. Yeah. Okay, so and add card. Okay, what I can do, I'm going to move hand back to before field. Next, I'm going to remove field itself. And I'm going to move the logic of hand to field. Next, add card, remove card ID. No, not ID. Index. So what we're going to do now is if index is bigger or equal to this card's length, return false. Const no, return this cards splice index dot 1 and 0. So we're always getting a card. Yeah. So okay, yeah. Next field. Okay. Yeah. I'm not going to mess with the field itself. So finally, let's add a new class called game. Constructor field players. Hmm. Is this? Oh, no, no. Field is going to be this no. Or what I can do is this field is new. Um, this players is new is new array new hand no no new deck comma new deck maybe no 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 um set hand player and hand if uh, hand instance of deck then this player so I can go with player one is one. So what I'm going to do is if player uh, smaller than one or player bigger than two, um, return false. So minus one is new hand hand. Field hand field is not in use anymore. Else if hand instance of hand this player minus one is hand, otherwise else return false, or rather return null. Um, maybe else if let real hand is null. So real hand is null. So okay. What I also can do is one or player is two, and then move this as as this, and change this to real hand. So x real hand is real hand. If real hand, no, wait, yeah, real hand turn. So if it's null, it's going to return false. If it's not null, it's going to return true. Okay, that's good. Okay. We get hand, player, if player let's see what hand has. Card, cards. Yeah, because I only want the cards of this hand. Player is 1 or player is 2. Return this player -1 hand. No card. It was cards. And it's lowercase b. So yeah. Yeah. Ooh, this is hard. And the thing is, I'm quite experienced with JavaScript. Imagine someone who isn't experienced doing something like this. Um, it's not just JavaScript; it's also planning the code. And most of the planning is in my head. But for most people actually need a model and an entire document of what they need. And I still, with my experience, I still do need documents um, to know what I am planning to do, what I want to do. So yeah, that it's programming is not easy. So yeah, okay. Um, yeah. How do we go from here? We can continue with this. So let's just do it. Let's create a booster. Um, I need a way to add cards randomly, and that's why I want to add booster. Okay, so a booster has a value of as a property opened, and it's by default it's false. Also has cards. Cards is an empty array. Um, so constructor set ID. All we need is a set ID. Um, so what did the set have? Get cards. So maybe I could this add set. Yeah. Okay. So set. So get static get card. Uh, Static get um uh, static get cards will only reveal the cards and their weight. So so what is a weight? The weight is basically it's dependent on its rarity or level. Um, let's first add the rarity of card. So let's go to card. Where's the card? Card is above. Get rarity, and in so rarity isn't a property that's normally defined, but we're adding a rarity getter. And what is rarity? Rarity depends on the level. Um, so level 10. So let's just do a switch. Switch this level. Case 10, return 4. Case 9 or 8, return 3. Case 7. Case 6, return 2. Case 0. Or why do we need a... Okay, let's see. Level 10 has... Yeah. Okay, we need to... Okay, so let's just default and return 1. There's also a last rarity I defined, that's rarity 0, and rarity 0 never occurs, which means that okay, well, maybe I can do this if this level higher than 10, return 0. Rarity 0 means you'll never encounter it. So these can be, for example, promo cards. Promo cards you'll never find in a booster. Um, yeah, I think I know something. No. Let's just keep it simple with this. Booster set ID, the set ID. So set get wait card set get card ID, get cards with an ID. So let's see if this sets ID return null. I could just do a set not found. So let's do that. Set not found. Second. The set could not be found. And in that case, we need to we're set add card, blah blah blah. Row. Set not found. Set not found. Okay. So we now have set not found. Next, const set is this sets ID. Set get, no, not get card. Can I access private? I guess I can. So but isn't necessary. We care for, what do we care for? We care for the set cards. Get name and cards. Maybe. Okay. Set cards. Object is set cards for each. Const cards is an object. Cards it's card ID. Card ID is and in this case it's going to be so get weight switch this rarity case 0 return 0 case 1 return 250. So the best way I could do this, or maybe I could do this just like so. Weights it's 0 to 50 50 10 1 50 10 return weights this rarity. So we have that. Cards ID is this. Oh wait. So yeah. Oh yeah. This cards card ID. Wait, maybe I can do. Oh, never mind. Let's just do this. No. Set get card d dot wait. So to test it out, we need to check it. So let's do set dot get cards, and then we go zip Let's see if that results into something. Console log undefined. That that surely isn't good, but return cards. And is it correctly? Is it correct? I think it's correct because level 4, if I was to do level 7, yeah, but it's level 4, so let's keep it level 4. So maybe add ghost, name, ghost, image, ghost.webp ranks. I don't know what kind of ranks level 7 cards have, so I need to look into it. Triple Triad cards. So, FF8 maybe. I need to look at level 7. Level 7. Okay, level 6 is boss card. Level 7 is boss card. But we already established that the first 5 levels are just yeah, that's going to be annoying. It's not annoying. Rarity 6. Yeah, if it's 6, it's still a boss. But that's not a problem. 6 is still manageable. Level 6. So let's see. 2, 8. Okay. Let's do 2, 8, 8, 4, and let's change this to 3 and 3. So side 4, 7. Yeah, 4, 7. Yeah, and this is a ghost card. So now if we look, the ghost card has a weight of it has a weight of 50, and that's good. So next, what can we do? We go back to objects. Let's go to game. Oh no, booster. We need to go to booster. So set dot get cards, set ID, const cards, const total weight is okay, let's see. I believe, okay, object keys, cards, reduce, card ID, okay, 0, and then Set get card, set ID. No. I don't need to do that. It's already stored in this local. So it's here to previous wait. Card ID is previous wait plus card ID. Did I do something wrong? S. Yeah, this is right. Next, const. No, don't let use const. Let wait is math floor math random times total weight. So next, what we want to do is object keys cards every. So every is a special method. It goes through the entire through an entire array and continues until it doesn't return true anymore. I believe. If is that function accepts up to 3 arguments, the every method calls a predicate function for every element in the array until the predicate returns a value which is coercible to the Boolean version Boolean value false, or until the end of the array. Okay, so exactly what I thought. So so card ID if okay, no we need to, so each booster has total cards is by default 11 cards. So for let ice is 0, I smaller than total cards, I plus 1. This part needs to be moved here. Let's move this line. Let's do this. If weight smaller than card ID, then return false, return true. So what do we want to do? So this cards push set ID colon card ID. So what does this function actually, this part actually do? So what I want to do is I want to add an X amount of cards. So by default 11 cards to the booster pack. And I want to add random cards to the booster pack. The cards are picked based on the weight. The higher the weight, the more likely a card is being added. So every iteration, I'll calculate the current weight value I want to use. So let's say we use these values. It goes from left to right in this. So first from Zape Dude to cat, snowman, ghost. If weight is lower than 250, it will add Zape Dude to our booster cards. Otherwise, weight minus is. So let's do const current card is current card. Let's do current card weight. Current weight. Current weight. So what so okay, so what happens now is um so if it's lower than 250, it just adds save to do to the cards. Otherwise, it subtracts 250 from the weight, then goes on to cats. Is it smaller than 250? Add cat. Otherwise, go to snowman. Otherwise, go to ghost, and it will always default to the last in the list. Which might not be ideal, but yeah, that it's something at least. Um, or no, maybe it is ideal. You want to um, maybe I should use a while here. While um, this card's length smaller than total cards. Yeah, so let's do this. So it will always try to get 11 cards. If it can't add a card, it will repeat the process until it has 11 cards. So yeah, that's net. So now use open booster. So what we now want to do is return this card splice 0, this card's length, and we want to set this opened to true. If this opened, return null. Do we also want a method to see if the booster has been opened? Um, okay, yeah. So to string if this opened, return booster already opened. Return this set. Okay. No, okay. This this cards map card ID set get card ID dot to string dot join. So yeah. So how do we test it? Well, let's do const booster is new booster, and we use JavaScript. Current card is not defined. Okay, that's cool. So on what line is current card? 179 here. Current card should be current weight. And that's true. Yeah. Console log booster length, not length, to string. Interesting. Console log this cards. So what does the get card method do? Return mama. So console log this sets real ID get card real card ID wait maybe to string. That explains everything. I didn't actually add implemented this toString method. So what should be in the toString method? So card, okay. That's interesting. Yeah, that's interesting. So return so let's do this name, this level, and what we're also going to do is this ranks join. Yeah. So now it randomizes perfectly. Yeah. This is cool. So now we have a booster. So and now let's look at this players. Yeah. Okay, let's see. The thing is, I'm trying to future-proof it, but that would make development a bit harder. So, and it's getting late. I didn't plan on streaming for too long, and right now it isn't too long. I can still stream until 12 o'clock. which is in an hour. Um, so let's see. Yeah. Um, yeah. So we can continue with this. So let's go. So what we want to do is async function init. And first thing we want to do is await load data. Let's run init. Save it and next. What do we want to do? Load the data is loaded. What is that? Oh, I don't know what that sound is. Okay. So what have we here? Dex reduce set. Okay. The beauty is we don't actually need to return. Oh, so it's okay. I'm tired. It's almost 10 p.m. for me, but I'll try to stay up until stream ends. Okay. Yeah, I guess that. Okay, the only thing I will do is okay. This is what I'm going to do. I'm going to do if I'm going to add something, and I need to look at some other code that I probably have written somewhere, but I am going to explain what it does, but it is going to take it won't take too long. I'm sure I'm going to dream about this song for a very 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 long time. Um, so I'm ready. So this is also what I mean with not um, not learning everything from everything code related, because so this is document ready state. So it checks if the document has already loaded. Um, and we're going to do this. So what this means is if the document ready state, if it says it's completed, it means that the entire document has been loaded. So from the top of here to the bottom of this, and this also includes rendering. So it waits until um, if the ready state is complete, that means that the document is render ready. So next, what I'm going to do is, if it's not complete, we're going to wait until it's completed. But to do that we need a promise. So what we do is await new promise resolve. We're only going to use resolve here. So next, const on ready is document remove event listener DOM content loaded, and also window remove event listener load. Finally, we're going to say resolve document add event listener DOM content loaded. Oh yeah, unready. I need to add unready everywhere, everywhere. Let's do this. And Let's do uh let's change this to this. Um, so what we can now do is console log set dot get cards zip list, and now we can see that this piece of code also works. Finally, um, what we need to do, and I need to check if okay, so this is good. We're going to create const game is new game. Oh, well, that's okay. Game is not defined. Um, is that okay? Yeah, that's okay. Triad. Let's do let game. Next. Okay, maybe I should move this part lower. Next, we're game is new game, and now we're technically done. So what I'm going to do is next time I'm going to further implement triple triad. Um, and so yeah, so for now I'm going to end stream. So if I'm going to look for someone to raid, if Shiji, if you're still here, can you do you have someone like someone I could raid Mutz or I could raid Ronan. Um, or I could also raid someone smaller. I have Pizza Cat who's playing Zapekist, and there's a few VTubers, a few who I haven't uh, watched often. I'm going to look. I do want to mostly do so. Yeah. Um. Hmm. I might go and rate Pizza Cat, but I first need to see what exactly the vibes are and how long they're streaming. Yeah. Okay. Let's do that. So let's go to the end screen. So next week we're going to continue making a triple triad. So let's raid. So yeah, it is already getting late for me, so I'm going to do some stuff for myself. Maybe play a bit Minecraft or watch anime. Um, and yeah, my head is a bit full right now, so I need to unwind. Um, and I need to get this damn song out of my head. So anyway, I hope you guys enjoyed it. So see you again soon, and good night. And enjoy the raid thingy. I don't know what I'm talking about. Have fun. Good night.